correct format. Okay, so the first phrase here: all cats are mammals. By the way, we don't care if it's true or not. Okay, we're just going to write it. Okay, here's how I would. Sorry, I'm all choked up over this stuff. It's so exciting. Here's how I'm going to write this first sentence using the universal quantifier. I'm going to say for all x in a specific domain. Okay, guys, what domain am I looking at for this problem? Not mammals, but cats, right? So for all x in the domain of cats, x is a mammal. Okay? That's how we would write that sentence using the format. Okay? So that's a universal quantifying format. Okay? Does that make sense, guys? It's not difficult. Okay? No differential equations, no integrals in there. Nice and easy. Okay? Every integer is a real number, or is a real numbers, apparently, because I'm no good at New English. All right? So every integer is a real number. Two ways we could write that. Okay? We could say, for all x in integers, x is real. Or another way that we could write that is we could write it a little bit more compactly. We could say for all x in a set of integers. Okay? Does anyone know what the symbol is for integers? What letter represents integers? It's not I, that's irrational.
N?
Not N, that's natural. Good try. So now you have a 1 in 24 shot. You know it's not 2. And you know it's not R either. So 1 in 23 shot. Not D. Good try.
That's what I want. It's a good one.
Z.
Z.
Yeah. That makes perfect sense, right?
Oh, well, of course.
Yeah, of course. In German, which was actually where the term integer was sort of formulated, Zahlen is the German word for integer. So that's why they picked Z for that. Okay. So if you guys are ever on Jeopardy and you get that question,
It's actually
I want
the German term for count, but that's
okay.
silence, multiple numbers.
Yeah, it's derived from the word. So, but okay. Sorry, I didn't know I had any Germans in the class.
What a good count. No, that is German, so
And I mean, that's what an integer is, right, guys? It's a counting number almost. It's almost like, except it's not negative, or it's negative or positive. And we could also say for all x and z, we could say x is in the real numbers. Okay. Make sure you guys can do it both ways. Okay. So if you guys see the letter z, from now on, make sure you guys know that that's an integer value. All right. There are students that study math. Okay. So that's not a universal statement, right? That's an existential statement. So the way I would write this, okay, is I would say there exists X in students such that X studies math. So take a look at the form of that, okay? It's almost the same form as the universal quantifier, right? Except we just switch the symbol. Instead of for all, we say there exists. And instead of the comma, we use the such that. Okay, so those are really the only differences. We still have a predicate. X is a mammal, which could be true or false depending upon what we throw in there. X studies math, what could be true or false depending upon what we throw in there for X. Okay? There's at least one bird that cannot fly. Okay, and again, we don't care if it's true or not. Does somebody want to take a guess, or does somebody think they might know how to write that?
There exists at least one bird that cannot fly. That's how, such that cannot fly.
Okay, so if I was to write
Such
that
that.
symbolically, the first thing I would write is the backwards E. Okay.
Okay. Then X.
Mhm.
Then that E thing.
As an element, good.
Then bird.
Okay, so X an element of birds.
Such that
Mhm.
one bird. So one bird or X bird.
X
Bird.
cannot fly.
X cannot fly. Okay.
Yep. Okay. And again, I mean, we know that's a true statement, right, guys? We can certainly find one bird that can't fly.
When we're answering the problems, should we use the such that symbol, or do you want us to literally write?
Oh yeah,
such
you can
that?
use the vertical line for that if you want to, okay?
Okay.
I'm just going about the way the textbook does it, because I don't want to do two different manners of it. But I understand that. You guys know that the vertical line means such that, fine. Okay? Guys, is this easy enough? Any questions about that? Okay, really easy stuff. Okay, Bart, go ahead.
So X is like you do in math, the domain, right?
X is a specific instance.
Specific instance.
Right. You're defining X to be one element in a whole domain.
Oh, the whole domain, okay.
But X is one specific value in that domain.
Gotcha.
Other questions, guys? Okay. Let's take a bunch of statements, determine if they're true or false, and let's justify a response. Okay? So, let's say the domain D is equal to 2, 4, 5, 6, 7. I want to show that for all x in D, 2x is less than or equal to 15. Okay? How do we verify that, or how do we disprove that?
You have to do the math on everywhere?
Just stick them in, right? So let's just evaluate. Okay? So I would do 2 times 2 less than or equal to 15. Okay, that's true. I would do 2 times 4 less than or equal to 15. That's true. 2 times 5 less than or equal to 15. That's true. 2 times 6 less than or equal to 15. That's true. 2 times 7 less than or equal to 15. That's true. Okay? And remember, this is a universal statement, so I have to show that all of them are true. Okay? Guys, what was that process called when we showed every instance satisfies the predicate? It starts with an E. Exhaustion, right? And now you know why it's called exhaustion, because you write it out and your hand's exhausted from it. Ha ha ha. That's the best math joke I have. Sorry. Alright. So, this is valid by exhaustion. So, if I was to ask you guys this on a test or a homework or something like that, yes, you'd have to show them all. Okay? The good news is I'm not going to give you guys like 500 or something like that. I'll just literally give you like 5 or 6, okay? And if anybody dies from it, let me know. I'll give you an A in the course. All right. The next one. Show that for all x in D, x cubed is bigger than 9. Okay? Now, what do we think about that statement, guys? Is that true or false?
False.
That's false. How come, guys?
4 cube is 2 cube.
2 cubed is 8, right?
Yep.
Obviously. So, let's do this. Okay? We would say 2 to the third is not bigger than or equal to 9. Okay? Clearly. Everybody in here knows this. Okay? Even Donnie that didn't pass algebra 1 apparently. Alright? So, guys, that statement is now false. And guys, how do we describe, or why is it false? Starts with a C. What explanation?
Contradiction?
Not contradiction, close. Rhymes with mount or example. Counter example, that's it. You just need the right problem, right guys? So this is false. This is B. By counter example. Okay? So we're just getting our reasons as to why they're valid or why they're invalid. Okay? Does that make sense, guys? That's how you either prove or disprove a universal statement. Let's take a look at some existential statements. Okay? So now we have F, which looks strangely similar to D, but so I decided to give it a new definition. So we have F equal to 2, 4, 5, 6, 7. Show that there exists an X in F, that X equals 1 over X cubed. Okay? Now, is that statement true or false, guys? That's false, right?
Okay.
Because no matter what number you plug in, it's not going to work, right? In fact, the only numbers that work are 1 and -1 for this. Okay? So, how do we show that there is no number in this domain that satisfies it?
So to do the exhaustion, how
Just write them out, right guys? You just write them all out and you go through and you exhaust all the possibilities, okay? So, I would say 2 is not equal to 1 over 2 cubed. I would say 4 is not equal to 1 over 4 cubed. I would say 5 is not equal to 1 over 5 cubed. 6 is not equal to 1 over 6 cubed. And I think there was a 7 in there, right guys? Yep. 7 not equal to 1 over 7 cubed. Okay. We have exhausted every possibility and we did not find a single instance that satisfies it. So we would say that this statement is false, and we say it's false by exhaustion.
So we can use the word invalid by exhaustion?
Oh, sure, you can say invalid, sure.
Okay.
It's the same thing to me. All right, easy enough, right, guys? For the last one, I want to show that there exists an x in I plus such that x is less than or equal to 7. Right?
That's
So
true.
I think the first thing we want to think of is, what does I plus mean to us? Like, what set is that?
That's not integer.
Not integers. Not imaginary, good try. Actually, imaginary is C for complex. That's actually pretty good, not a bad guess. Irrational, very nice, okay? So, whenever you see I plus, that's positive irrationals, right guys? So, I plus, or it's just a really bad blood type. So, positive irrationals. And we know what an irrational number is, right guys? It's a number that never terminates, never repeats.
Pi.
Okay? Like
E.
pi, right?
E.
E, okay? Square root of 2, okay? In fact, aren't those all numbers that are less than or equal to 7, right?
Yep.
So there's actually a multitude of numbers we could pick, okay? So we could go ahead and say something like pi is less than or equal to 7. Well, there we go. We have just found a positive irrational number that is less than 7. So the statement is true because we found at least one. Now we started rattling off a few more. We said e, the natural exponential base. We said square root of 2. Okay, but this is valid by, okay? And if you can find at least one instance, it's not exhaustion, but it's another E word. What is it, guys? Existence, okay? So this is valid by existence. There exists at least one. Okay. So, now we know how to prove, now we know how to disprove these. Okay? The problem is, what happens when we start defining, bless you, what happens when we start defining domains that are infinite? Okay? Bless you. Okay? That's actually going to be in the next part of the course where we start studying direct proof. Like for instance, I could tell you the sum of two even numbers or even integers is even. How would you prove that by exhaustion? You couldn't, right? Because there are an infinite number of even numbers, okay?
In this class, are there such things as like fallacies or something
yeah.
like that?
Sure, we could run into, and you would actually disprove that by contradiction, okay?
Okay, yeah, there's this thing like how we would refer to those. So okay, if we're gonna get there, then you don't need to say.
Yep, don't even sweat it for right now, okay? Worry about that in about 3 weeks. Okay, other questions, guys? All right, so the next thing I want to talk about is a universal conditional statement, okay? We know what conditional is, if then, okay? So, if I study, then I will pass, okay? If I show up to work, or if I show up Monday, then I will get the job, okay? What I want to do is, I want to write one of these sorts of things, okay? So I want to write it in a sentence, and then I want to go the other way, and I want to write it symbolically, okay? So let's just go ahead, try to decipher what this says, and then we're going to go ahead and write it symbolically, okay? These aren't too difficult. All right, so, our first one, we have all x and z, if x squared is even, then x is even. Okay? Does somebody want to try to tell me what that's actually saying to us? Like if you had to describe that to a 9th grader or a 10th grader or
For
something like that.
all integer x, x squared is even if x is even.
Okay, so for all integers, okay, and we're going to try not to use any variables whatsoever, because a variable is considered a syntactical or symbolic sort of item. Okay, we don't want to use any symbols. So for all integers, then what? If the integer is squared, right? So if the integer is squared, or if the integer squared is even, sorry. So if the integer squared is even, then what, guys?
The integer is
Then
even.
the integer is even. Good. Okay. So we just want to make sure that we replace x with what the actual name of it is. Okay. So for all integers, if the integer squared is even, then the integer is even as well, or we could just say is even, okay? So, when I ask you guys to translate into a sentence, no variables, okay? All you guys do is you just literally use English words, okay? So, like I said, like just because just imagine like there's no variables or there's no syntax in the sentence whatsoever. Okay. The next example, okay? All y in n plus, if y over 2 is in z plus, then y must be even, okay? Well, part of it's already done, must be even. So, I guess my first question is n plus. What does n plus mean?
N is, what the things, N,
Natural numbers,
Natural number.
okay? So, n plus means positive natural numbers, okay? So, what we would say is, for all positive natural numbers, then what? How do I write the rest of that? Anybody want to
if natural number divided by 2,
Okay, so if the natural number, I like it, divided by 2, or half the natural number,
is part of the integer, positive integer,
is an integer. Okay, we could just say is an integer.
is an integer, positive.
It's a positive integer, thank you. Sorry, I forgot that there was a plus up there. Is a positive integer. Okay,
Then the natural number must be even.
then the positive natural number,
Must
or we
be-
could just say the natural number, that's fine. Because we defined it to be all positive natural numbers, so we already know we're only dealing with those initially, okay? So, if the natural number divided by 2 is a positive integer, then the natural number must be even. Alright. Yeah, it's a pain in the butt, I know, to write these out. But the whole purpose is just to make sure that you guys can express what's being said, okay? And I think that's one of the things, like sometimes